Welcome to point channel. Today I will discuss about at the rate one to many unidirectional association, that is from parent entity to child entity side. Okay, so I'm going to cover what is this annotation at the rate one to many, and when do we need to use this annotation, and since we are going to add this particular annotation at the parent entity side, so how to insert and fetch parent entity records, and similarly how to delete a specific parent entity record, and is it really possible to delete a specific parent entity record without deleting the child entity records. Okay, so and similarly how to delete either one record or all child entity records of a specific customer ID. Customer ID in the sense here in our case, parent entity ID. Okay. So yeah, we will cover all these scenarios in this demo. Yeah, without wasting time, let's jump into the coding part. Yeah. So in my previous video, I have already discussed about at the rate many to one unidirectional association from child to parent. So this one. So now I am going to cover at the rate one to many unidirectional association from parent to child. Okay. So let me delete all these things. Yeah. So here, if you see, I have considered the same example. So here, if you see, this customer is an entity, so which acts as a parent entity. Okay. So and here, if you see loan, so loan is a child entity. So that means one customer can have multiple loans, and multiple loans can be associated to one single customer, right? So in my previous video, I have already discussed about at the rate many to one annotation. So at that time, we just had this type of what do you say code snippet in the child entity, right, just to establish a connection from child entity to parent entity side, right? So at that time, we don't have any association within the parent entity. So now in this demo, okay, since we are going to discuss in a reverse side, that means parent entity to child entity side, right? So that's why I just commented this piece of code. Okay, so in fact I will remove this. Okay, so here if you see, hardly we have three fields: loan ID, amount, issued date. So now we need to have at the rate one to many annotation, something like this. So this is a parent entity. Now if you see, we need to have, obviously one customer can have multiple loans, right? So so we need to have an something collection like either set or list, anything you can have. So list of loans. Okay, I just created an empty array list. Okay, so now here, we can pass multiple attributes as per our requirement. So this is the first attribute. Cascade is equal to cascade type dot all, or any specific action also you can specify. For example, if you are interested in only saving operation, then you can keep persist, cascade type dot persist. If you are interested only removal operation, cascade type dot remove, or something like that. So here I just specified all. Okay, now fetch is equal to fetch type dot lazy. This one also I already covered. So whenever you fetch a parent entity record, so that means customer record, so it will not fetch its associated loan records in a same call. Okay, so that's the beauty of fetch is equal to fetch type dot lazy. So here this orphan removal is equal to true. So this also we will discuss after some time. Okay. Um, so now here if you see, so we have only customer repository. So why? Because I am going to do all the operations with respect to customer only. Why? Because we have established a association from customer to loan, but not from loan to customer, right? So that's why I have only customer repository. Okay. So this is just a main class in which we have annotated with the Spring Boot application. That's it. Okay. So here if you see, we have one utility package. So this is a just a class. Just to showcase the lazy loading. Okay, to overcome that lazy initialization exception, I just wrote one separate class that we will discuss later. Okay, so yeah, this is just a application dot properties in which I just maintained database specific properties for MySQL database. Okay, so this is just it. test case. Okay, just to explain all the scenarios. Okay, now now we will go through one by one scenario here. Okay, so uh, before that, I mean, let me show you in the database. Okay, here, let me refresh here. You can see we don't have any tables. Okay, all the tables are empty. Okay, so now here if you see, I am creating two sets of records. So if you see the first set, okay, so I'm just creating customer record. So obviously I need to pass only two fields, customer ID and customer mobile number. Okay, and three loan records. Here three loan records. Okay, so here since we don't have association from loan to customer, so I am not passing this customer as an argument to this particular loan, like how we did in the previous video. So do note this point. So now how I am linking all these loan records to this customer in the sense, okay, something like this: customer one dot get loans, okay, dot add all. Okay, either I mean you can do individually also. Get loans dot add of personal loan one. Again, one more step. Get loans dot add of home loan one. Something like that also. I mean, I just added in a single shot. Just add all. So I just converted to in the form of list, arrays dot as list of something like this. So now what I have done, I mean, I just linked all these I mean, all these three loan records to this particular customer one with the help of this particular statement, this statement. Okay. So then we are good to save this particular customer. So now I'm just simply saving this customer. So now what happens? See here, do note this point. I mean, we are not saving this loan records, but since we have cascade is equal to cascade type dot all, so in which persist is also one of the action. So that's why here, since we are saving a customer record internally, it will also save associated loan records into the loan table. So that's the beauty of cascading. Okay. So the same operation we have done even for the one more set. Same customer two. So this time customer two has only two records, personal loan and home loan. Okay. So now let's execute this particular test case. Okay. Okay. So now um, let me tell you one more point. So here if you see, whenever we add at the rate one to one or at the rate many to one, okay, internally it's creating one new foreign key column, right? So that's what you have observed so far. But here, I mean, even in order to create a foreign key column within this customer table, okay, within this customer table, but what you say, how can it accommodate this kind of one-to-many relationship? Means one customer can have multiple loans, right? Customer one has loan one and loan two. So how do we do mapping? Even though if you create a foreign key column within the customer table, it's not possible, right? So that's why what it does internally Hibernate, it will create one more table, something with the name like customer underscore loans or something like that. Okay, in which it will maintain two columns. I mean, primary key column of customer and what do you say, primary key column of loan. Okay, so just give me 1 minute. Yeah, I'm sorry. Um, so yeah, here you see test case passed. Okay, let's examine the database. Here I'm just refreshing. Okay, yeah, as I said, see, we have customer table, we have loan table, and we have one more new table that is customer underscore loans. So now I will show you. So here, if you see, um, yeah. So first we will see, yeah. So this is the loans. Okay. So total five loan records I just created. Here you can see one, two, three, four, five. Okay. So first three loan records are linked to customer one, and fourth and fifth records are linked to customer two. Okay. So now here. I will show you we have two records, two customer records, one, two. Okay. So now here the linking operation has been done in the new table. As I said, I mean table name is customer underscore loans. secondary key column of customer table, and loan underscore ID is the primary key column of loan table. Now here you can see clearly first three records 1111 is linked to these three loan records. Means customer one has three loan records, and similarly second set means customer two, a second customer has two loan records, that is 4 and 5. So, so like this, I mean, whenever we have at the rate one too many, internally Hibernate will create a new table. Okay, new table something like this. Okay, so now we can see the rest of the operations also how it does. Okay, so yeah, so here if you see, yeah, so this is just a fetch customer. I mean, if I fetch only what is a customer, then what happens? So I mean, obviously, I just wrote what you say this piece of code in one more class, that is lazy testing. Why I have written in the sense, obviously, it will throw lazy initialization exception whenever I try to fetch its associated loan records, right? So that's why here you can see where it is. Yeah. So here, if you see, I'm just running this. Okay, what I'm doing here, if you notice, I'm just fetching what you say. Uh, yeah, I'm just fetching its customer record whose ID is one. Okay, I'm just verifying its customer name Rajendra and customers dot get loans dot size. Okay, so obviously first customer has three loans, right? So I'm just cross checking whether it has really three loans or not. Okay, so now see test case is passed. Okay, so the I mean this is how we have verified the this fetching operation. Okay, so now if you see we will see two more operations. So here delete customer. Okay, so what happens if I do delete by id? Okay, so customer repository dot delete by id of 1l, so that means I want to delete a customer record whose id is 1. Now if you see in the customer, okay, so if you see cascade is equal to cascade type dot all, right? So this all internally consists of remove operation also. Okay, remove operation also, so that means whenever I remove parent record, that means customer record, internally it will delete its associated loan records also. In fact, it is required also. I mean, if you, for example, if you don't specify this all, okay, if you don't specify this all, let's assume you specify only persist. Okay, then what happens? I mean, when you try to delete a parent record, okay, obviously, uh, I mean, internally it will throw a foreign key constraint violation exception. That means without deleting its associated loan records first, database will not allow you to delete its parent record upfront. Okay, so this is a basic fundamental database rule, right? So whenever we want to delete a parent record, first we need to delete its associated loan records, then followed by this deletion of the parent entity record. So that's why it's mandatory to keep both persist and remove. So that's why I just mentioned in a single shot all. Okay, so then happily what it does, first it will create its first it will delete its associated loan records, then finally it will delete its parent record. Okay, right? So we will see the same. So where are we? Yeah, so here I'm just running this. So here if you see, once I delete this customer, I mean, I'm really cross checking. I'm trying to fetch this customer whose ID is one. So obviously, if it is really getting deleted, I mean, this statement, what do you say, gets executed. I mean, this will return true. So because customer data is present, obviously it's false. I'm cross checking as false. See, test case is passed. So now if you see the database, okay. So obviously here, see, first customer record will be deleted. Now if you see, if I refresh, see, I mean, um, first customer record is getting deleted. We have only one record, that is whose ID is 2. Now, if you see loans record, first three records will get deleted. So you can see, boom, okay. Only we have two records, that is customer 4 and 5. And even from this table also, here you can see, even from this table also, see, we have only second set, that is 2 2, customer ID 2 2, here 4 5. Okay. So this is what we need to delete this customer record. Okay. So now, um, so this one, uh, delete by customer ID. So that means I don't want to delete parent entity records along with its child entity records. That's what we have seen till now. Okay. So I want to keep its parent entity record. So that is customer record. So but I want to delete only its associated loan records. Okay. So then how to do this? Okay. So for example, here what I'm doing, if you see, um, yeah. So first I'm fetching a customer record whose ID is one. Then if you observe here, customer dot get loans dot remove of zero. So that means what I'm doing. So obviously this customer has uh, two loans, right? I mean whose ID is two. If you see two, we have two loans. So I'm just trying to remove of first loan record of this second customer. Okay. So as soon as I remove the first loan record of this second customer, then what happens internally the respective foreign key column gets updated with null. Okay, but it will not delete that record from the customer table, sorry, from the loan table, that is child table. So um, so in order to delete that particular loan record, okay, which has a foreign key column of null, so for that we need to add one more attribute, that is nothing but orphan removal equal to true. Okay, so now since I have added this one, so here if you see, um, yeah, so let's execute this particular test scenario also. So yeah, so here if you see, obviously I'm cross checking customer.getLoans.size. So if it really gets deleted, the size will become 1. Okay, so if test case is passed, in the sense, I mean this operation went well. So post this execution, we will cross verify this MySQL workbench. See here, you can see test case is passed. So here if you see, as I said, now parent entity record is intact. So that means parent entity in the sense customer record. So here if you see, yeah, so this is customer, right? So I'm just refreshing. See, as I said, this record is intact. So I'm not deleting this parent entity record. So that is customer record. So I want to delete its associated loan record and to first record. So obviously here if you see, we have till now two loan records. So I'm just going to refresh. Obviously first record will get deleted now. Okay. So here if you see, yeah. So now first record gets deleted. Obviously its as respective association also gets deleted even from this particular table. Here you can see, yeah, boom. So even it got deleted, right? So so this is what I mean I want to discuss here in this video. Okay, so I also want to discuss one more scenario here in this demo itself. Okay, so here if you see, after adding at the rate one to many, so now just now we have observed, I mean it has created a new table with name customer underscore loans, right? So is there any way to what you say, not to create this kind of new table? Is there any way to have straight away foreign key column in the loan table itself? That means here, so yeah, so in the this is a loan table, right, which has ID, amount, issued date, somewhere as a fourth column, something like this customer underscore ID as a foreign key column. Is there any way, in the case of at the rate one to many unidirectional association? So here if you see, why I'm trying to say here is, in the loan we are not going to have any association from child to parent entity. So but even then, is there any possibility to have foreign key column within this particular table? Okay, so yeah, so let's see that one. So for that what we need to do is, okay, here, come here. Okay, so here we need to add one more annotation, that is at the rate join, okay, sorry, yeah, join column, sorry, name equal to, Yeah. So I'm just adding one more annotation just below to this at the rate one to many, just at the rate join column name is equal to customer underscore ID. So what does it mean? So till now it has created a brand new table with customer underscore loans, right? With the name of customer underscore loans. So now, uh, as soon as I add this particular annotation at the rate join column, right? It will not create any new table. In fact, it will create a one more foreign key column within the loan table. So that means somewhere here as a fourth column, it will create the customer underscore ID in this. So then altogether we will have only two tables, that is customer and loan. Now the only difference is in the loan we are going to have a one more column or one more foreign key column, something like customer underscore ID. Let's see the same now. Okay, so now I'm just deleting all these tables. Okay, so here if you see, uh, yeah, yeah. So now let's run the same scenarios once again. Okay, so I just want to show you the difference. Okay, so here, come here. Okay, yeah. So when I insert the records like how I did earlier, so now altogether we have only two tables, that is customer and loan. Okay, so in the loan table we are going to have one more column, that is customer underscore ID. Okay, so yeah, let it run. Yeah, so just trying to refresh. Yeah, here you can see it has created two tables. So now I'm trying to fetch customer records. So here you can see it has created two customer records. Now, obviously, there is no table with customer underscore loans. So now, if you see loans record, I'm just refreshing. Obviously, five records will be there. Okay, yeah. So here, as I said, now you can see fourth column. This is nothing but a foreign key column with the name customer underscore ID. Okay. So now, if you see uh, first three records, first three records, that is loan one, two, three are associated to customer one, and loan four, five are associated to customer two. Okay, so how this column has been created in the sense with the help of this particular annotation at the rate join column name is equal to customer underscore ID, which we have added just below at the rate one to many. Okay, so now if you see the even the remaining operations, okay, so remaining operations are also more or less same like how we have discussed just some time before. Okay, so yeah, so but even then I just want to show you. Okay, okay, so this is fetch operation. Okay, so yeah, it will. So overall, I mean, in both the cases, case one and case two. So case one, we just have at rate one to many annotation, okay, in which it has created a brand new table with the name customer underscore loans, in which it has a primary key column of customer table and primary key column of loan table. Okay, second case is case two. I just added just sometime before at the rate join columns, just below at the rate one to many. Okay, so now it has not created a new table. In fact, it has created a one more foreign key column within the loan table with the name customer underscore ID. So just now that's what we have seen. So even if you see test case is passed, okay. And if you see even these two test scenarios also, here also we can delete this customer record and so it will take one more minute. Let's see these two cases also. Okay. So here I'm just deleting this particular customer. Okay. So obviously it will delete a customer record and its associated loan records. Okay. It will take a while. Just bear with me. A test case is passed. Let's examine the results. Okay. So here if you see, we have hardly two tables. Now I'm just deleted. Why? Because I just deleted a customer record. Here you can see. Obviously, customer record, first customer record also gets deleted, and its associated loan records are also gets deleted. Why? Because yeah, I deleted only customer record, right? So now I just want to delete loan records of a customer. What you say here? You can see first loan record of a second customer. Okay, so this is what I'm trying to do. Okay, so now if you see here, I mean, if you come here, I'm just running this. This is the last test scenario of this demo. So once this test case is passed, obviously here you can see this first record gets deleted, and this customer record will be intact. Here nothing will happen. Okay, we are going to delete only the loan record of second customer. Okay, so just bear with me. Yeah, here you can see test case is passed. Okay, so now I'm just refreshing. Yeah, see customer record is intact. We are not deleting anything from the customer side now. If I just refresh, obviously first record gets deleted. This is just because of orphan removal equal to true. Okay, so this is what I want to discuss here in this video. Okay, so I mean, just we will recap the key points what we learned so far. Okay, so the first key point is, so if we add iterate one to many in the parent entity side, okay, so it will create a new table. Okay, so with the name something customer underscore loans. Okay, so yeah, so we need to add something like this. Then we will have altogether total three tables: customer and loan and customer underscore loans, right? So that's what we have observed. Case one. Now case two. So now, if I add at the rate join column, here you can see this at the rate join column just below this at the rate one to many. So then what happens? It will not create a new table. In fact, it will create a foreign key column in the child table, that is loan table. Okay, with the name customer underscore ID. So then altogether we have only two tables, that is customer and loan. That's what we have observed. This is a case two. So now for both case 1 and case 2, okay, these are the common operations. So here if you see, if we keep cascade is equal to cascade dot persist, obviously whenever you save a parent entity record, internally Hibernate will save its associated loan records also in the single shot, in the same call. Okay. So uh, so I mean, we no need to save loan records separately. So that's the beauty of cascading. If you delete, I mean, if you save customer record, so that's it. Internally, it will save its associated loan records. The same operation, the same thing even here also. Here, if you see, it is highly recommended to keep cascade is equal to cascade dot remove at parent entity side. Okay, so then whenever you delete a parent entity record, obviously its associated child entity records are also gets deleted from the database. Okay, suppose what happens if I don't give cascade is equal to cascade dot remove, then I mean Hibernate, I mean what do you say, it will throw foreign key constraint violation exception. Why? Because without deleting its associated loan records first, how come you are trying to delete a parent entity record? So like that, I mean it's a basic fund database rule, right? So by that way, I mean we will get this foreign key constraint violation exception if we don't specify cascade is equal to cascade dot remove. So this is a important point, right? So and one more last point, yeah, so if at all I want to delete any child record of a specific parent, so then I just need to what you say fetch those child records, and we can just simply remove with the help of remove, like what we did customer dot get loans dot remove of 0, like that, right? So suppose if you want to delete all the child records of that customer, so simply customer dot get loans dot clear, that's it. So then I mean immediately internally it will delete all its child records from the loan table. So then how it's happening? So that is because of orphan removal equal to true. So that's the beauty of orphan removal equal to true. Okay. So yeah, this is what I want to discuss. Yeah. Thanks for watching my video. If you really like my video, so please like and share and subscribe channel. Thank you.